Hello, everybody. My name is Rached Blili. I am the CTO for network automation sales within the mass scale infrastructure organization. And it's my pleasure to be here today to present to you an introduction to the Crosswork Hierarchical Network Controller. So what is the Crosswork Hierarchical Network Controller? We call it HCO for short. It's a controller that sits above the entire network. It gathers all the different network domains, exposes a single abstraction of multiple domains and multiple layers of the network, and basically creates what we call a digital twin of the network. Part of its responsibility is to decompose service management requests that come in from a higher layer called the end-to-end service orchestration layer. It decomposes those into the requirements for different domains of the network and dispatches service management API calls to those lower level controllers. But let's back up a couple of steps and understand why it is that we need this hierarchical network controller in the first place. So the problem itself is that we address a giant black hole in the way that typically networks are automated and run. There's a very data-rich layer within service provider networks, which is usually up in the IT and the OSS, where people really understand how to create automations, how to program APIs, how to program user interfaces, how to manage different things. That includes things like the inventory system. It includes things like data center management and things like that. But when it comes to the actual network itself, typically service providers are operating on a lot less information than you might think. There's been a journey that we've been through where we're gradually bringing network automation to these types of organizations. And if you've been involved with Cisco and NSO, you're quite familiar with some of the efforts that we've been championing in that regard. But there's still a significant problem that has been historically very difficult for service providers to manage. And it is simply this. The way that a typical network is built, yeah, you might not always be thinking about it, but in order to connect two routers that are separated by a large distance, there's a number of things that have to occur. Obviously, cabling has to happen. You have to have somebody connect the cable from one device to another. But typically, that IP link is going to be carried over some sort of a fiber infrastructure. It may actually traverse several networks before it reaches its ultimate destination. Even a single point-to-point IP link, there could be several different network domains involved in providing the connectivity for that. Um, in addition, the way that service providers tend to grow is by acquisition. They tend to build out networks for different services. So there's a variety of network domains, there's a variety of different network layers that are all kind of operating in silos. And they oftentimes have dedicated network operations teams just to be able to run those networks. But from a high level, from a CTO level, let's say, within the service provider, they're used to thinking of their entire network as just this one thing that delivers services to their customers. So being able to reconcile that holistic understanding of the network and the actual operational reality, which is siloed operations and siloed considerations, has been very difficult. This is actually made worse by the fact that the management platforms that are typically used to run networks are usually focused on a specific network domain. So you may have, for example, an optical network, and there's an optical network management platform. Its concern is that particular optical network, not the way in which that network connects to other networks. So the HCO's primary value is that it actually brings all of those things together. It's focused on the different parts of the network that connect to other parts of the network. Meaning, how does a router connect into the optical network? How do different optical networks connect into each other? How does the aggregation network connect into the core network? All of those different places that tend to be at the borders of the network management sphere of concern are the different puzzle pieces that the HCO is bringing together. And so you have a single network model, a single understanding of how traffic can go across the network, and importantly, a single understanding of how different parts of the network depend on each other and serve each other's purposes. Once we have this understanding, we can do all sorts of things. We can visualize it, we can analyze it, we can automate it. It's just a key capability. So what this ends up providing service providers is a service to fiber view of the entire network, a complete network derived way to understand the entire network and its interdependencies. So what does this typically look like, and how does the HCO fit into the software ecosystem? I'll take a little step back here and I'll define a term here. I've already used the term controller, and it's important for me to be able to convey to you guys what I mean by that. And what Cisco means by controllers is a piece of software that does three main things. It exposes things, it manages things, and it assures things. Controller has been used. Sometimes we say orchestrator, sometimes we say controller. Everybody's got a slightly different understanding of what that language means. But in this case, and in this presentation, when I say a controller, I do mean these things, right? So a controller is able to understand a network topology, is able to understand a service topology, is able to capture active network inventory, and is able to understand how the network is performing. So it exposes all of those things. You can actually query those things via an API, and it maintains the state of those things on the fly. So there's a full understanding of the connectivity that's involved within a specific network domain. It's also responsible for managing the services, right? The create, the modify, the delete of services across the infrastructure. It's able to compute paths for those services based on certain criteria. So you're asking for the service to perform at a certain level, to perform a certain role or function. It should be able to compute a path that optimally carries the service across the infrastructure and the topology that it understands. And in addition, it should maintain, it should optimize itself, it should optimize the topology, it should make sure that the SLAs are maintained. And if the SLA is under threat due to some sort of a network change event, it should take steps to make sure that that SLA is preserved or signal some sort of a fault northbound to some higher level function. So the HCO is a hierarchical network controller, and in context, it looks a little bit like this, where it sits right here, right above the domain network controllers, but right below the multi-vendor cross-domain orchestration. So what are all these layers, right? So at this multi-vendor cross-domain orchestration, you have services that in order to instantiate a service, sometimes you may need some compute, sometimes you may need some storage, sometimes you may need to compute to configure some sort of an access networking type of configuration. But there is a transport, like fundamentally, how do you get the service from one place in the network to another place in the network? That's the transport domain, right? And the hierarchical controller, HCO, sits basically at the top of this particular sub-hierarchy. It's responsible for the network. And the network is comprised of several different networks, the IP network, this optical network, maybe a microwave network. HCO's job is to talk to the different controllers that are each in charge of different sub networks or of different network domains, and bringing all of those together into one place. You may be wondering, by the way, this is an NSO conference. Where's NSO in this picture? Well, in Cisco, NSO is actually inside pretty much every single one of these boxes. NSO is inside the HCO. It is the provisioning engine for HCO, just like it's the provisioning engine for Crosswork Network Controller, or CNC. NSO is everywhere as an ingredient in all of these different products. So just a little bit of a quick reminder about what the different layers in the hierarchy provide. I've got several functions listed here. It's really important to understand how they're divided. I'm not going to go into in great detail over here, but suffice it to say that there are some significant benefits to having this hierarchical model for deploying controllers. And one of the key benefits is it unlocks the ability to innovate for the service provider. The service provider is our customer. The service provider has a ton of investment up here at the OSS, at the IT, at the service orchestration layer. That's where they're frequently developing. This is where most of the DevOps type of people that they've hired over the last several years are typically concentrated. And what we want is we want for them to be able to evolve that without all of the disruption that is typically caused by churn that happens down here in the network. This architecture allows vendors that provide equipment to innovate quickly with their own controllers. So as their controllers evolve, as their platforms evolve, they're able to provide the latest and greatest controller to manage them. But as they do so, there's another layer here, the hierarchical controller. It's responsible for maintaining the API interactions with those controllers and it creates a stable interface for this layer here to be able to talk to the network. So the kind of language that's happening between this layer and this layer is, I need to connect this part of the network to that part of the network with these performance characteristics. The HCO takes that, decomposes it, and says, in order for me to be able to do that, I would need to have maybe an IP circuit, or maybe a pseudo wire, or maybe a layer 3 VPN, and it would need to be optically diverse. And so I need to make sure that I have a path on the optical network that's this way or that way. And then it communicates with those controllers. Each one of them takes their little piece of that service, their little piece of that SLA, and then tries to do the best thing that it can with it. That's really, really a really fast overview of that. I'd be happy to go into more detail with you guys in a separate time. An example of what that really means, what that translates to for a service provider, is basically that the HCO would allow the service provider, this is a slide that we got from Vodafone, for example, where they're using the HCO in order to manage services all the way from the cell tower into the tech centers, the entire path of that service, whether it's traversing the microwave network, whether it's traversing an IP network, or whether it's being routed along different paths inside the optical network, is entirely managed by the HCO, which decomposes the entire end-to-end service and farms out little pieces of it to the individual controller that's responsible for that. In the case of Cisco and some important initiatives that we have, the role of HCO is very, very crucial to routed optical networking, which you may have heard of. This is a groundbreaking new technology that Cisco has been championing, where we bring the optical network and the optics into the routers themselves, simplifying the network architecture. But the fact is that even such a new technology is going to be incorporated inside of a brownfield or an existing network. And so there's going to be a variety of technologies involved in carrying a service. And it's really important to be able to unify that entire thing. HCO is able to do that. HCO is able to trace a service across a classical DWDM infrastructure, watch it traverse the routed optical network, and maybe terminate somewhere else in the network. Maybe, perhaps it's being delivered via OTN or something like that. So that's the key role that HCO is going to play. It's going to be something that's going to that you're going to hear about anytime that you have a service provider that's managing multiple network domains and multiple network layers. And I'm going to show you a little bit more about how that works in a demo that's coming up right now. All right, so we're inside the HCO graphical environment right now. This particular application is called the Explorer. It's just an ability that we have to visualize the network. It's a 3D UI that lets you pan around, tilt, zoom, and lets you explore the network graphically. I'm just going to give you a quick tour of what it looks like, explain to you what you're seeing, and then I'll delve into the features of HCO. So what we're looking at here is, for example, the Paris site. This is a layer 3 site. This is a site that contains routers, and you can see the 3 routers inside the Paris site. I click into one of them. We see that it's a Cisco routers, and we can look at the ports on that router, scroll through different types of ports. We can look at the links that originate at that router, see what the other side is. It's just a basic way to explore the topology of the network. That little pane on the left is called the sidebar, and it gives you information about whatever it is that you've got selected. I'm going to go now and I'm showing you just the optical network alone, right? So I'm going to go to this Italy site. You can see an optical site that's denoted by this squarish kind of icon. Optical is always denoted as squares. IP is always denoted as circles. So we're looking inside the Rome site here. We can see that there are 2 optical devices. Here's a ROADM. It's a Sienna ROADM. We can see its ports. It's a completely different types of ports here. We got OCH, ODU, OMS, OTS ports, and we can explore those. And then we can switch to the multi-layer view, where it shows us both layers at the same time. I'm going to get a little closer to the Barcelona site here to show you the interlayer connection here. We call that a cross-link. You can see this little vertical pylon between the layer 3 site and the optical site. And when I click on that, it's going to show me in the sidebar a list of the cross-layer connections. On the left, you see the router ports. On the right, you see the ROADM ports. And this connectivity is actually really, really hard to keep track of in a typical network. HCO brings it together in one place, and you're able to, and is able to build a model of the network that incorporates all of that information. You can see the benefit of that right here. I've selected Paris to Barcelona, and you can see that selection in orange. And then in green, what you see is the actual optical path that the circuit between Paris and Barcelona is taking. There's actually two circuits here. I'm going to select one of them, and I'm going to expand the path in the sidebar, and you're going to see this view here that we call the subway map. On the left, you have the logical IP link, and as you go to the right, you can see the different layers of the network from Ethernet to ODU, OTU, which is the OTN network, OCH, OMS, OTS. These are the DWDM layers. And you can trace the circuit all the way from Barcelona to Marseille. You can see the wavelength that is being carried on to Marseille. You can see that it stops over in Lyon, hits a ROADM over there. You can see all the amplifiers on the way there, and you can see the circuit terminating in Paris on a ROADM there, and there it resurfaces all the way up the hierarchy until it terminates right there in CR2 PAR, which is the core router in Paris. So we're able to trace that IP circuit from end to end. We can do it in the reverse way as well. Here I'm selecting an optical segment. It's an OMS between Marseille and Barcelona, and I can see two things lighting up in green: the Paris to Barcelona link, as well as this other link that goes from Milan to Barcelona. You can see that they're both being lit up because they both pass through that segment that I selected. The ability to understand how things are connected is really, really powerful. What I'm doing right now is I'm going up the stack instead of going down. Instead of showing you what's below a link, I'm showing you what's above. You can see that I've selected a link, an LSP here. Now, this particular LSP happens to go through that IP circuit that I selected between Paris and Barcelona. You can see its path originates in the UK and terminates in the north of Spain here. Just like I could do with the IP link, I can do the same thing with an LSP. I've expanded it, and I can see it's a full multi-layer path. This is allowing me to actually trace the LSP from its source to its destination while fully understanding every bit of infrastructure that's responsible for getting it there. From the LSP to the routers, you can see I'm going into the optical network. You can see it crossing between two routers in Paris here. I'm scrolling by fast because it's a pretty long path. And then you can see it reaches destination, like it passes through Barcelona, it crosses from one router to another again. It goes through another wavelength, and then it reaches its destination in the north of Spain, where it hits the core router 2 and then moves over to core router 1, and then that's where the LSP ends. Trying to understand every device that an LSP is traversing is actually an extremely difficult problem, but within HCO, it's just one click away. This is really useful when we look at failures. For example, I'm looking here at a failure that's happening on this link. That's why it's red. And I'm going to expand that. Now I see that same red being shown in the sidebar in the subway map view. And if I look at the red, I can see that it propagates all the way down the layers, but here you can see the red does not go as far as it does up there. So actually this one here, this OTS segment, is the root cause of my failure. It's the reason for everything above it being down. It's an OTS segment. I'm going to click the locate button. It's going to zoom me right over to it. You can see in light green, in light yellow here, that's the OTS segment right there. This is the segment. And you can see in green, all of the links, nearby links that rely on it. So if I unselect here, I should be able to see that all of this stuff should be down. If that OTS is down, those should be down. And indeed they are. Right? You can confirm that for yourself by selecting some of them individually and confirming that their path does indeed take them through that segment. You see that one goes there. This one here that goes off in a different direction, nevertheless crosses over that same segment, as does this one. So the fact that that OTS link, this is a fiber failure that's happening in rural UK, is causing these failures, international failures, all the way to Germany. And that would be an extremely very difficult thing to find. There's a bunch of failures on this network, and we don't want to hunt and peck through all of them. So we'll launch this root cause analysis application that just gives them to us on a list. This is simply showing us the lowest layer failure in the network, all of the lowest layer failures in the network. This is the one we were looking at just now. There are actually 3 other failures that are happening at different layers in the network. There's this OMS, which is a link between 2 ROADMs. It's down. It's between Marseille and Milan. And there's another failure happening in central Spain here. That's also at the OMS layer. And here's something that's just an IP link that's down in Eastern Europe. This list is all of the root causes. And then if you look at the affected links column, it shows us the number of affected elements. So we're going from the disease to the symptoms here. It's saying if you've got this disease, you should expect to see these symptoms. In the case of the OTS that we were looking at, 681 affected links. If I select all of the different types here, you'll see that there's actually 640 LSPs that are down, 10 ODUs, several IGP links. If I apply my filter, I'll see them all in this list. You can see everything that's down. You can scroll, you can search, you can identify if some customer is calling, you can figure out why it is that it's down. Even layer 3 VPNs that are down as a result of this particular OTS failure. It's all in one place, and you're able to understand exactly what's going on without having to go from management platform to management platform or calling different people to tell you this information. It could take days or weeks sometimes to identify these correlations between things happening in different parts of the network. So the HCO has a number of applications. We can actually look at the device inventory, the network inventory, because all of the stuff that you're seeing in HCO is derived from the network itself. Here we're looking at devices, optical network elements from different vendors, where we can look at the routers that are in the network. We see all of them here. We can search, we can sort. As a matter of fact, we're collecting inventory information from these devices. So this router here that's in Dusseldorf, I can look on the side over here, and it's actually captured the inventory, and I can see the different ports that are in use and how they're hierarchically arranged within the device. Or I can click through different tables. They're kind of a little bit off screen here, but I can look at the different cards that are all over my network. I can search for part numbers. I can search for serial numbers. I can run analysis. And everything that you see here is available via API. This is just a graphical representation of the information that's stored inside HCO. But remember, HCO is a controller, and everything that you see graphically is intended to be consumed programmatically through our northbound interface, including some of the more advanced analytical capabilities. For example, here's an application called the Network Vulnerability Tool, and its job is to identify scenarios by running type of simple what-if scenarios, identify scenarios where the network itself is broken into different pieces. So you can see here that this dual failure of an IP link and an OMS link has actually split the network into 3 pieces. You can see them here. There's a yellow part in the north, there's a yellow part in the south, and there's the blue and red in the middle. These 3 parts of the network can no longer reach each other. Here's a completely different scenario that causes the network to be split in half. You can see the yellow part on the right. It cannot reach the other part that's on the left. And the cause is these 2 failures happening in the network. So it runs through all these scenarios and highlights different ways in which your network can be segmented. There's other applications like the services manager that lets you build and manage services. You can run failure impact analysis so that you can plan your maintenances. But because this is a developer conference, I'm going to show you the Sedona hierarchical query language. This is a special query language that was developed just for HCO, and it lets you do things like look through the data model and see what's there. A simple query, I'm just going to build a simple query here. I'm going to look for inventory item of device family ROADM. This is basically saying, show me all of the ROADMs in my network. You can see that the UI is kind of guiding me as I type, so it is interactive. And here's all my ROADMs. I have 169 of them. I click here and I can see that there's 3 different vendors. I can actually filter and sort, of course, but here I'm just going to actually filter based on vendor just to be able to look at just those 49 Cisco ROADMs here. Okay, I'll run that. And this is launchable by a REST call. It's a simple GET request, and all of the output is formatted in JSON. Let's say I'm just interested in looking at the ports on all of the Cisco Layer 1 devices. Here they are. There's several different categories of ports. Let's take a look at what one of those ports looks like in JSON. You can see that all the different attributes that are captured. These are the same attributes that are represented in the table. There's one attribute called type, right? Let's say that I'm actually interested in looking at the optical channel ports inside the Cisco optical devices. I'm getting more and more specific here, right? So I'm going to choose OCH ports inside the query. You see, by the way, I moved from inventory item to port with that pipe character, and now I'm going to move from port to link. So I'm transforming from one type of data to another with that simple operation. So what I'm looking at here is optical channel links that pass through Cisco ROADMs, right? And the query is getting kind of interesting, but let's get more interesting. Let's say that I don't want to look at optical channels. I just want to see what rides above those optical channels from a hierarchical model perspective. And here you go. I just went upward and it shows me all of the layers above OCH, all the way up to layer 3 VPN. Let me focus in on LSPs here. So I'm going to take my results of the upward function and I'm going to limit them to links that are in the LSP layer. So I should see only LSPs after I run this. But now let's say that I'm actually interested in taking that information and integrating it. I'm not just running this query out of curiosity. I want to take that. I have some sort of business intelligence platform that just wants to keep track of LSPs running through Cisco ROADMs. And it's expecting the data to be formatted in a specific way. And so I'm going to use the view feature here to kind of structure my table, my output table, which again, I remember can be accessed via REST interface and is formatted in JSON. I'm going to have it format the output in a very specific way: source, destination, and the LSP bandwidth. Okay, I'm going to run that. And so I went from a list of ROADMs to a list of ports to a list of links to a list of LSPs, and I'm now formatting the output in a specific way. And here you go. So this kind of operation is extremely difficult to do in most situations because it's actually crossing domains, it's crossing layers, and you can see that the SHQL language actually makes it really simple. You can save your queries so that you can either call them by API in a single call, or you can refer to them later. Here's another query that's even more kind of complex. This particular query, I am interested in looking at all my layer 3 VPNs and understanding which ones are going over an optical network. And I would like a breakdown of which types of devices carry my layer 3 VPN traffic through the optical network. You can see that most of my VPNs are going, there's 22 Sienna devices and 5 Corian devices and so on and so forth involved in carrying my layer 3 VPN traffic. Here we are. Here's the list, and you can see the counters. You can use, by the way, the counters to populate dashboards inside of HCO, so you can keep track of certain reports that you're running and set thresholds and monitor those in dashboards, or you can alert based on those things. It's an extremely powerful language. And I thought it might be interesting to this group as being a group of developers. So that was my super fast introduction to the Crosswork Hierarchical Controller. Remember, it is a platform that allows you to look at your network in a very, very unprecedented level of detail and interconnected way. It creates the digital twin of the network. It lets you do things like zoom in and look at street level detail for how your fibers are run and understand exactly how those relate to the IP network. Okay, so that's all the time that I've got. It was a pleasure presenting to you. If you'd like more information, I'll be around all day and I'd be more than happy to meet you. Otherwise, you can check out information about HCO inside the Cisco website. And if you have any interest in learning more, or if there's some questions that you might have that I might be able to address, please feel free to reach out. And thanks for having me.